Hello everybody, let's check out the hot and cold water problem on page 171, number 59, okay? So you're running water into your laundry sink to get a mixture that's 1/2 hot and 1/2 cold water. The hot water pours in at a rate of 7.8 liters per minute. The cold water pours in at 12.3 liters per minute. So that one's obviously faster. Okay, we know that a hot water supply comes in more slowly. It has to heat up in your hot water heater, but there's always cold water available. You especially know that if you're taking a shower as the last person in your family, right? Okay, so question A asks us, and it tells us first, it says, let the time for the hot water be called T. So that's the time for the hot water. And since the cold water pours more quickly, okay, at a faster rate than the hot water, we need to start that a little bit later. So in fact, they tell us that you wait on the cold water and you give the hot water a head start. And you start the cold water 2 minutes later, okay? So if the time for the hot water is T, what's the time for the cold water? Okay, you start at 2 minutes later, so we're going to call this T minus 2. So whatever time is, it's going to be measured in minutes. You're going to take the time of the hot and subtract those 2 minutes. And that is the time for the cold water. Okay, and now we're going to take, we're going to do a little bit of unit analysis and just look at what formula will find us how much liquid we have for the tub, okay? Our total liquid is going to be a rate times the time. Okay? Now you can associate this formula like with speed equals distance over time, and then we change it all around. You put the distance here, the time here, whichever one you want to solve for. But this rate times time is actually going to give us the liquid, which is measured in liters. And let's just take a look at that, okay? So my rate is in liters per minute. And my time is going to be measured in minutes. So just take a look at that unit analysis. Can't we cancel those minutes? Cancel, cancel. And I'm left with liters. Okay, so we're going to find out how many liters of hot and how many liters of cold. And what we really need to do with those then is set them equal to each other. Because when they're equal to each other, it means that it'll be a half and half mixture, half hot, half cold. Okay, so there'll be equal amounts. So we're going to take those two formulas with the rate times the time. Let's do it for the hot water on this side. Okay. So the hot water is 7.8 liters per minute. And now we're going to multiply it times the time for the hot water, which is called T, the hot water. And now we're going to find the rate for the cold water, which is 12.3 liters per minute. And we multiply it times the time for the cold water. Well, what is the time? It was 2 minutes later than the hot. So that's called the T minus the 2, right there, okay? And now we need to solve. Now I'm going to get rid of the unit analysis in this problem, okay? Let's just look at the numbers, and it's going to be 7.8 times T, times the time, equals, is equivalent to the cold water, which is going to be 12.3 times T minus 2. Now don't you see the distributive property there? So let's go ahead and do that. We get 7.8 T equals 12.3 times T is 12.3 T. 12.3 times negative 2 is going to be negative 24.6. If I subtract 12.3 T from both sides, I get 7.8 T minus 12.3 T. And that's going to equal negative 24.6. So this is different signs difference. So the larger number is negative. Our answer is going to be negative right there, and we'll see that both of those negatives, the one on this side and the one on this side, are going to cancel out, and we will get a positive amount of liters, okay? Actually, time is what we're solving for. So let's go ahead and solve for that. Let's see. The 7.8 minus the 12.3 is going to be 4.5. And it's going to be negative 4.5 t. Okay, those were like terms. Both of them were t's. And now I have negative 24.6 on this side. I need to divide both sides by this negative 4.5. And you can see then that I've got my negative and a negative makes this positive. And I'll keep writing across here since I'm just done. And this is going to equal 5.46 if you do it on your calculator. And that 6 is going to be repeating, okay? So let's make sense of this, okay? This formula right here, setting the two sides equal to each other because we want it to be a half and half mixture of half hot, half cold. So those liquid measures have to be equal. That's why we did that. But now I've got this, and I have 5.46 repeating. And now I need to just make sense of it, okay? So if I'm gonna make sense of that, I would really say, well, I would round that to something that makes more sense. And I would just say, oh, well, that's really like 5.5 minutes. And this is measured in minutes. So that's 5.5 minutes. And what did I solve for? Well, we didn't see it quite here, but it is true that these canceled out and you were left with t on this side. Those cancel. So t is equal to approximately, and I should have put an approximate sign there, okay, 5.5 minutes. So 5.5 minutes. So if that's t, t stands for the hot water. So that's how long the hot water will be running. So if I ask you how long the cold water is going to be running, you say, oh, well, we started that 2 minutes later, so I need to subtract 2 from that right here, okay? So 2 from the 5.5 minutes will get you 3.5 minutes, okay? So that's the amount of time that the cold water is running, all right? So that's the hot, cold laundry problem. See you later.